Welcome to This Explainer. Today, we're diving straight into a totally crucial topic for all of us, component architecture. Now, I know looking at a list of technical terms can sometimes feel, well, a bit dry, but we're going to transform these concepts into a vibrant, living blueprint for building significantly better software. You can really think of it like constructing a physical house. You absolutely need a solid foundation before you can even think about putting on the roof, right? Without a well-thought-out structural foundation, your codebase rapidly becomes a total nightmare to maintain, debug, and scale. You essentially end up with a house of cards that's just waiting to collapse under the weight of its own complexity. But don't worry, we're going to avoid that entirely by mastering these foundational pillars. Here is our blueprint for today. We're covering 6 pillars, starting with the foundation of folder structure, the power of reusable components, resolving prop drilling, lifting state up wisely, mastering composition, and finally, ensuring separation of concerns. So every robust application really relies on these 6 branches working in absolute harmony. You got to think of them as an interconnected ecosystem, branching out from the core concept of component architecture. If just one branch is weak, say your separation of concerns fails, or you completely ignore how state is lifted, the entire structure gets compromised. They don't just exist in isolation. Your folder structure dictates exactly how you organize those reusable components, which in turn directly affects how deeply you might have to drill props, which then requires lifting state and composition to resolve. Mastering how these 6 elements interact is literally the key to getting your digital house in order, and more importantly, keeping it that way as your app grows. All right, let's jump into pillar number 1, the foundation, which is our folder structure. So, folder structure is your root directory organization. It establishes the literal foundational blueprint of your software project. Look, we've all seen a folder structure that looks exactly like a digital junk drawer, right? Files thrown everywhere, zero clear naming conventions, just absolute chaos. But a clean, organized structure acts as that solid, concrete foundation. Consider the massive difference between organizing purely by file type, putting all components in one folder, all styles in another, all hooks somewhere else, versus organizing by feature, where everything related to a user profile lives neatly in one dedicated module. Establishing a clear, feature-based root directory early on prevents you from wasting hours searching for a single file. Plus, it ensures that as your app grows, it doesn't just sink into the mud. Moving right along to section 2, the power of reusable components. Reusable components are basically the modular bricks of your digital house. They save you time and prevent all that tedious, repetitive work. Think about building a brick wall in real life. You definitely don't manufacture a unique, custom-shaped piece of clay for every single spot in the wall. No way. You use standardized modular bricks. In software, these reusable components make constructing the rest of your application incredibly efficient. But honestly, more importantly, it centralizes your logic. You write the code once, you test it once, and you use it wherever you need that specific functionality. This drastically reduces your surface area for bugs. If a button component has a styling issue, you fix it in one single modular file, and boom, that repair instantly propagates throughout the entire application. Next up, section 3, resolving prop drilling friction. Okay, prop drilling. It is the tedious process of passing data through multiple, deep layers of your component architecture. Imagine trying to run a water pipe from the roof all the way to the basement, but you have to manually cut a hole through every single floorboard, ceiling joist, wall stud, and insulation layer along the way. It is a massive, overwhelming architectural headache that just completely bogs down your whole system. Forcing data through layers of components that honestly don't even care about that data creates unnecessary dependencies, and it just slows down your entire development process. Let's say you're passing a user's profile picture down the structural tree. You start at the top component where the user data is fetched, then you are forced to pass it to a middle component that only handles the sidebar layout and literally doesn't even care about the picture. Then it goes to a generic child component, and finally, after all of that unnecessary routing, it reaches the target profile component. It is incredibly brittle. If one link in that chain breaks, or if that middle component accidentally alters the prop, your data flow stops dead in its tracks, and your target component renders a broken image. Well, let's take a step back and breathe for a second, because section 4 is our elegant fix for all that friction. Lifting state up wisely. Lifting state up is this wonderfully elegant solution that centralizes your data so it can be shared seamlessly across multiple components. Instead of forcefully drilling that data down layer by layer like we just talked about, we just place the state in the closest common ancestor of the components that actually need it. By lifting the state up to a shared parent location, both sibling components can access the data as a single reliable source of truth. You completely bypass that massive chain of middlemen components, maintaining a super smooth, logical data flow that is incredibly easy to trace from your debugging. Just look at the difference here. Prop drilling creates immense architectural pressure. It's a tangled, leaking mess of unnecessary connections that's multi-step and heavy on friction. Compare that to the centralized elegance of lifting state up. It literally turns a multi-step nightmare into a modern, highly efficient plumbing system where every endpoint gets exactly what it needs instantly. By keeping the state centralized, you ensure that any updates to the data instantly re-render only the specific components relying on it. You aren't forcing arbitrary layout components to reprocess data they don't even use. All right, moving into Section 5, Mastering the Composition Pattern. So the composition pattern is the methodology of bringing all those smaller pieces together to form a highly flexible, robust final structure. And guys, this is an architectural masterpiece because it actively prevents what developers commonly call wrapper hell. Because we took the time to establish those reusable components early on, we can now build complex user interfaces by simply snapping simple, independent components together, just like Lego bricks. It's so much better than building massive monolithic 1,000-line files. It relies on passing components as props or leveraging slots to weave them into a robust, unified architecture that accommodates change without totally breaking.
In practice, mastering this takes 3 simple steps. First, you identify your independent reusable components. These are your raw materials, like buttons, cards, or layout grids. Second, you assemble them by wrapping components around each other and passing child elements directly, allowing them to interlock seamlessly. Finally, you deploy this flexible overarching structure. By following these logical steps, you avoid rigid, deeply nested hierarchies entirely. Your application is going to scale beautifully, easily adapting to new requirements, mainly because you're just rearranging independent pieces rather than tearing down whole walls.
Finally, we've made it to our last pillar, Section 6, Ensuring Separation of Concerns. Separation of concerns is the core architectural principle, ensuring each section of the app handles only its specific designated responsibility. Think about it. You absolutely do not want your plumbing mixing with your electrical work, right? Well, in code, this means keeping your user interface rendering completely isolated from your complex business logic, your state management, or your API calls. If a component is built just to display a list, it should not also be responsible for fetching that list from the database. Keeping every single part focused solely on its own specific job makes your app dramatically easier to test, debug, and maintain. So we've covered everything from foundational folder structures to the final polish of separating your concerns. But ultimately, it all boils down to one provocative question. Is your current architecture actually built to scale, or is it just waiting to collapse? The decisions you make about components, state, and structure today will absolutely dictate whether your app survives tomorrow. Next time you open your codebase, ask yourself if you're building on solid concrete or just adding to a digital junk drawer. Thanks for joining me on this explainer, and keep building smart.